Hello students, this video is about uniform circular motion. So as the name suggests, it is a circular motion which is uniform. So we can define uniform circular motion of a particle such that if a particle moves along a circular path with constant speed, then its motion is said to be uniform circular motion. So in the term we have two main parts, that is circular means the path should be in the form of a circle, and uniform means same speed throughout the motion. So इन्हीं दोनों को combine करके we can define uniform circular motion as the motion of a particle is said to be uniform circular motion if that particle moves along a circular path and with a constant speed. So if the particle is moving with a constant speed and its path is along a circle, then in that case its motion is said to be uniform circular motion. And now with constant speed we mean that it should move such that it cover equal distances along the circumference, because the path is circular. It cover equal distances along the circumference in equal intervals of time. Alright, so this is the uniform circular motion. Now one more point is here to add on, that uniform circular motion is an accelerated motion. This kind of motion is accelerated motion. So how we can say it as accelerated? Since the speed is constant throughout the motion, still we are saying that it is an accelerated motion. So reason for it is, suppose a particle is moving around this circle with center O and radius vector r, and that particle is moving anti-clockwise, means in this direction. So direction of motion of the particle at any point is given by the tangent drawn on that point. So if we draw a tangent on the circumference, on the point of the circumference, then by that tangent we can give the direction of motion of that particle. So if we see carefully, if you observe it, we can see that the speed of motion is constant or is uniform, which means that it cover equal distances over the circumference in equal interval of time, but at every instant, at every point, the direction is changing continuously. So the direction during the circular motion is changing continuously at every point, which shows that speed or the magnitude is same but direction is changing, which means different velocity vector will be there at every different position of the particle. For every separate point, every different point, every different position of the particle, we will get a new velocity vector, although the magnitude of that velocity will be same because the speed is constant, but the direction for it is different. Since velocity is a vector quantity and it depends on both vector and magnitude, means direction and magnitude, and if even one of them is changing, we can say that velocity is changing. So because of the change in direction, the velocity vector or the v vector that is perpendicular to this radius vector keeps on changing continuously due to the continuous change of the position or due to the motion of the particle across the circumference, And since the rate of change of velocity is acceleration, so this motion, this uniform circular motion has acceleration because there is a change in velocity. Since there is a change in velocity, so acceleration exists there because acceleration is equal to rate of change of velocity. So the main point is we call it as accelerated motion because although at every point speed is constant, but the direction of motion is changing continuously at every position. Since at every position it is changing continuously, which means that the speed is constant but velocity keeps on changing continuously throughout the motion particle move across the circumference. The velocity keeps on changing because of the change in direction. And since there is change in velocity, so we can define rate of change of velocity, and rate of change of velocity means acceleration. So that is the reason we call that the uniform circular motion has acceleration, or it is a kind of accelerated motion. So this is the reason for that. Now after this, there are some important terms which we should know when we are studying about uniform circular motion. So we are going to discuss those terms that are related to uniform circular motion. First term for uniform circular motion is angular displacement. Displacement gives us the change in position of the particle. Since now we are studying circular motion, so particle is moving on a circular path, that's why the term angular displacement is introduced here. Suppose the particle is moving along this circle having center at O, and this is the reference axis. I am taking this as a reference axis. Now at time t1, particle is at some point A having this distance is equal to r and making angle theta 1 with the reference axis. Now this was a position at time t1. After some time at the new position, this is the new position, suppose at time t2. So again the distance of this position from the center is r, but angle is changed now. Let this angle be theta 2. Okay, this angle is theta 2, and the arc or the distance covered by the particle from A to B, let it be delta S. Delta S denotes the arc or the distance that is covered by the particle while moving from A to B. So now angular displacement of a particle that moves along this circular path is actually equal to the angle that is swept by its radius vector. So its radius vector is, suppose this is the radius vector and it swept from position A to position B like this. Okay, so इसका angle change हुआ because of this change of angle. The change of angle जो हमें मिला, that change in angle is called angular displacement. So we can define angular displacement as the angle swept by the radius vector in the given time. राइट, गिवन टाइम में जैसे यहाँ पर हमारे को टाइम गिवन था t2 माइनस t1, दिस इज द टाइम इंटरवल डेल्टा t, और इसमें हमें चेंज इन एंगल मिला डेल्टा थीटा, लेट इट बी डेल्टा थीटा, एंड इट्स वैल्यू विल बी थीटा 2 माइनस थीटा 1, मीन्स द रेडियस वेक्टर ओ ए स्वेप्ट टू इट्स न्यू वैल्यू ओ बी, और इस बीच में जो एंगल आया that angle is equal to this, means theta 2 minus theta 1, and we represent it by delta theta. So angular displacement is delta theta, which is equal to theta 2 minus theta 1, and according to the formula that angle is equal to arc upon radius, and from the diagram we can give delta theta as delta s upon r, means this is the arc upon radius of the circle. Now if we talk about the unit of angular displacement, so it is an angle, so its SI unit is radian, and it is a dimensionless quantity, dimensionless because it is an angle, so it has no dimension, and its unit is radians, and its value is theta 2 minus theta 1 or delta s upon r. So the angle swept by the radius vector in the given time interval during circular motion is called angular displacement. Second term after this that we have to study is angular velocity. When we study linear motion, in that case velocity is equal to displacement upon time. That means rate of change of displacement of a particle give us its velocity. Similar in the case of circular motion, the only change is instead of displacement it will be angular displacement. So angular velocity gives us the rate of change of angular displacement of a particle. So the time rate of change of angular displacements instead of displacement, because we are dealing with circular motion. So the time rate of change of angular displacement of a particle is called its angular velocity, and it is denoted by omega. So we can denote it by omega, and its unit is radians per second, since it is angular displacement per unit time or the rate of change of angular displacement. So its SI unit is radian per second. Radian is for angular displacement and per second gives us the velocity. So if we consider a particle that is in uniform circular motion, and if delta theta is the angular displacement of that particle, this is the angular displacement in time interval we take is delta t, in time delta t, then the average angular velocity, if we are talking about average, then we write it as omega bar is equal to delta theta upon delta t. Now if we want to know the instantaneous angular velocity, means if we want to find the velocity at a certain time instant, that is instantaneous angular velocity omega, then for that we have to take limits for delta t tends to 0 over the average angular velocity. Means अगर हम इस interval को if we try to shorten this time interval such that it tends to 0, then it becomes an instant, it is equivalent to an instant, then the velocity we get will be instantaneous angular velocity. So instantaneous angular velocity can be given as limit delta t tends to 0 delta theta over delta t, or we can write it as d theta over dt. This is the instantaneous angular velocity. Its unit is radian per second. Next term that we should know in circular motion is time period, which is very common. So time period is the time taken by the particle to complete one revolution along its circular path. Time period is time taken by the particle to complete one revolution along its circular path. पाथ को ट्रैवल करने में एक साइकिल के लिए एक सर्किल कंप्लीट करने में कितना टाइम लगेगा, दैट इज कॉल्ड टाइम पीरियड. Okay, time period, or sometimes we also call it as period of revolution, right? Sometimes it is also called as period of revolution. It is denoted by capital T and SI unit is seconds. So time period को हम capital T से denote करेंगे and its SI unit is second. Next thing is frequency. So mathematically तो we know that frequency is the inverse of time period or reciprocal of time period. Here we can define frequency as the number of revolutions completed per second or per unit time. So unit time में कितने revolutions that particle will complete is called frequency. Frequency is defined as the number of revolutions completed by particle per unit time. This is called frequency and it is denoted by the letter nu. Okay, this is the letter nu, nu. We call it as nu and it is equal to the reciprocal of time period. It is equal to the reciprocal of time period. How it is equal to the reciprocal of time period? So as per the definition, we know that new revolutions are happening in 1 second. Okay, new revolutions in 1 second, that means one revolution in 1 upon new second, and this is the time period only na. One revolution जितने टाइम में होता है that is called time period. So time period is equal to 1 upon nu, that means nu is equal to 1 upon t. So frequency and time period of the circular motion are reciprocal to each other. Now we can also find the relation between omega, nu and t. Angular velocity, time period and frequency के बीच में भी we can find some relation. Let's do that. We know that capital T is the time period. That means in time t, the body covers one complete revolution over the circular path. If this is the path with center O and radius r, then the body cover one complete cycle in time t, and if it cover one complete cycle, that means the angle traveled will be 360 degrees, or we can also write it as 2 pi radians. So what we know is capital T is the time period in which one revolution will be completed, or 2 pi radians of angular displacement will be covered. This we know. That means when T is equal to capital T, that is the time period, theta means angular displacement is equal to 2 pi radians, and if it is so, then angular velocity, that is omega, will be angular displacement upon time. So it is theta upon t, and we can write it as omega is equal to 2 pi upon t, because theta is 2 pi और 1 upon t is 2 pi nu. So omega और t के बीच का relation हो गया omega is equal to 2 pi t, 2 pi upon t, or we can write it as omega is equal to 2 pi nu, because 1 upon t is equal to nu. So these are the required relation between omega, nu and t. These are the relations, and nu is equal to 1 upon t. ये तो this we know already. After this, we can also find a relation between linear velocity and angular velocity. So now we are trying to find relation between linear velocity of the particle and angular velocity of it. For this relation, we consider a particle moving along a circular path as shown in the diagram. Particle is moving along the circular path of radius r. Now assume that the particle moves from point A to point B in time delta t. So in time interval delta t, particle move from point A to point B and cover this distance delta s along the arc or along the circumference of the path, that is AB. Now in this case, angular displacement of the particle, that is delta theta, angular displacement of the particle, that is delta theta, can be given as delta s upon r. That means angle is equal to arc upon radius. Now we can divide both sides by delta t. Dividing both sides by delta t, we get delta theta over delta t is equal to 1 upon r delta s over delta t. Now to find the value of angular velocity omega, we have to take limits such that delta t tends to 0. So let's take the limits. Taking limit delta t tends to 0, we get limit delta t tends to 0, delta theta over delta t is equal to 1 upon r, because r is constant, that is the radius of the path, limit delta t tends to 0, delta s over delta t. So we can write these values as this is d theta over dt, or we also write it as omega. So omega is equal to d theta over dt is equal to 1 upon r ds over dt, and ds over dt is the rate of change of displacement, means this displacement, that is linear velocity v. V is equal to होता है ds over dt. So we can write omega is equal to, this is the same thing, omega is equal to v upon r, or v is equal to omega r, and this is the required relation between linear velocity and angular velocity of a particle. So linear velocity is equal to angular velocity into radius. In vector form, it can be written as v vector is equal to omega vector cross r vector. That means for a given angular velocity, the linear velocity of a particle is directly proportional to its distance from the center. Okay, so that was the relation between linear and angular velocity. After this, the next term that is related to circular motion is angular acceleration. So just as linear acceleration, we know that linear motion में acceleration was the rate of change of velocity of a particle in motion, इसको हम acceleration बोलते थे. And now here in uniform circular motion, the time rate of change of angular velocity, this time it's not velocity, it is angular velocity. So angular acceleration is the time rate of change of angular velocity of a particle is called angular acceleration, and it is represented as acceleration and it is represented by the letter alpha. So इसको represent करने के लिए हम alpha का use करते हैं. For average angular acceleration means if delta omega is the change in angular velocity in time delta t, then average angular acceleration, that is represented by alpha bar. Alpha is the representation of angular acceleration and we are saying average angular acceleration, so alpha bar is equal to delta omega over delta t. For instantaneous value we have to take the limit, then instantaneous angular acceleration, that is alpha, will be limit delta t tends to 0 delta omega over delta t, or it can be written as d omega over dt. And SI unit of angular acceleration is radians for angular displacement, then for velocity it is radian per second, and now for angular acceleration it is radian per second square. So SI unit is radian per second square and it is denoted by alpha. Now we can also find the relation between linear acceleration and angular acceleration. Since we know the relation between linear velocity and angular velocity is v is equal to r omega, so by using this we can find the relation between linear acceleration and angular acceleration. For that we have to differentiate both sides with respect to time t. That means dv over dt is equal to d over dt of r omega, but the motion is uniform circular motion. So r, the radius remains constant, then it will be r d omega over dt. So we have dv over dt is equal to r d omega over dt, where dv over dt is linear acceleration a, this is radius r, and d omega over dt is angular acceleration alpha. So a is equal to alpha r is the relation between linear and angular acceleration, and in vector form it can be written as a vector is equal to alpha cross r. So this is the vector representation of this relation. This is angular acceleration. So after all these terms, the last term that we have is centripetal acceleration. Since we know that whenever there is a body in uniform circular motion like this, its speed remains constant but its velocity changes, and that change in velocity is because of the change in direction of motion of that particle, and that's why the motion is accelerated. So a body that is undergoing uniform circular motion is actually acted upon by an acceleration, and that acceleration is actually directed along the radius towards the center of the circle. So that acceleration which is acted upon the particle during the circular motion is along the radius and towards the circular towards the center of the circular path, then such acceleration is called centripetal acceleration. So centripetal acceleration can be defined as whenever a body undergoing uniform circular motion is acted upon by an acceleration which is directed along the radius towards the center of circular path. Since its direction is towards the center, that's why it is called centripetal acceleration. So this acceleration is called centripetal acceleration, and it is denoted by simply A and is equal to v square upon r. Also, this acceleration remains constant in magnitude, but its direction continuously changes and remains perpendicular to the velocity vector at all positions. Okay, so this magnitude is constant and its direction is changing and remain perpendicular to the velocity vector at all positions. This acceleration is called centripetal acceleration, that acts along the radius of the circular path and it is towards the center of that circular path. So that's all for the uniform circular motion. For further videos, stay tuned, keep studying. Thank you.